Hi folks, we're going to take a look at 7a from page 375. So here we have an exponential equation that they want us to solve, and hopefully you're going to start recognizing some signs as to what type of method we should use. So here I notice that there's three terms. Okay, there's an 8 to the x and there's an 8 to the 2x, and that 8 to the 2x can be written as 8 to the x squared minus 2 times this same expression, 8 to the x minus 5, and hopefully you can see that this is starting to look a lot like a quadratic trinomial. Okay, and in fact if we do a change of variable, okay, hopefully you get to the point where you don't need to do this, but if you do, I'd say keep doing it, is let's let 8 to the x, this expression that repeats with the variable, let's replace that by some other variable, say z. So now I can rewrite this as z squared minus 2z minus 5 equals 0. And here I definitely recognize this as a quadratic equation. Okay, so at this point here I'm going to solve for z, okay, with my usual methods for doing that, and then I'm just going to re-input 8 to the x and solve the exponential part of this equation. Okay, so here we look, two numbers that multiply to negative 5 and add up to negative 2, and clearly nothing's going to work, so we're going to have to use the quadratic formula. So z is going to be equal to negative b, so 2 plus or minus b squared, which is negative 2 squared, 4, minus 4 times 1a times c, which is negative 5, all over 2a, so 2 times 1. So we get z can be equal to 2 plus or minus, so this is going to be 4 plus 20, so 24 over 2. Okay, now because I actually have to work with this number a little bit further, I'm gonna simplify this, okay, because I think I can make this look a lot nicer. So 24 is 6 times 4, and of course 4 is a perfect square, so square root of 4 is 2, so this is going to be 2 root 6 over 2, and now let me distribute this divided by 2, so this is going to be 1 plus or minus root 6, okay? But it's not z that we're trying to solve for, it's 8 to the x. So that means that 8 to the x can be equal to 1 plus root 6, or 8 to the x can be equal to 1 minus root 6. All right, now we can solve this. Now before I go on, I'm hoping that you're going to notice that root 6, regardless of what it is definitely larger than 1, and so 1 minus root 6 is going to be negative. Okay, so this is going to be going to give us no solution. Okay, since 1 minus root 6 is less than 0. Okay, and there's no way for an exponential expression to be equal to a negative number. So this is what they're talking about when they're talking about the extraneous roots. Here we have a root to this quadratic equation, 1 minus root 6, which is a solution to the quadratic equation, but is not a solution to the original equation that we're actually solving. Okay, and we're going to see that we're going to talk a lot more of these extraneous roots. So that's what it means. It's a solution that you find that doesn't generate an answer to the original equation. Okay, so we're not going to work with that. So we just have to work with this here. And so I'm going to, see if they're asking me to use, they're not asking me to approximate this answer, so I'm just going to do this in the easiest way. I'm going to take log base 8 of both sides, so I have x is equal to log base 8 of 1 plus root 6. Okay, now if I did want to actually find an approximation, well, of course, and I'll just put in brackets just in case we need to do it, you would just use a change of base. So this is log base 10 of the original input, so 1 plus root 6, okay, over log base 10 of the original base, which is 8. So that's an alternative form for the answer. All right, so let's go back and recap. So we've seen now that we can recycle some old methods for solving these exponential equations, and it's all about writing them in a form that allows us to use one of our old methods. In this case here, solving quadratic equations. So once I get it into this form, I can solve it by traditional methods. However, when I re-input my exponential expression, I have to be careful that I only solve things that actually are solvable. So here, I can't take log base 8 of a negative number, so we'll take this away. This generates no solutions. Okay, that's it for this one.